Hello everyone, how are you? I hope that all of you are might be fine. Today we are going to study the very important subject, that is science. But before that we must know what is about the science, what does it mean, what is the use of science in our real life. Each and everything surrounding that happens and why it happens, it is because of science. The science is a systematic study of a nature or universe where we can study the various phenomenon in our everyday life, in a practical life, that exist a science. So that study is based on the observations we have made every day, and it is about the experiment and conclusions. Science is a simple systematic study of nature and universe based on observations, experimentations, and logical reasoning. It tends to know that how the things happen around us. It means, for example, if I ask you what are the real life examples which exist the science, these are the many examples that you can give to anybody. Many examples in our day-to-day life. For example, why anybody if drop the ball from the height, it falls down. It is because of the gravity that pulls the ball towards the earth center. That is the science, and that comes under the physics. So breathing process is also the science. Then the substance are existed in various forms based on the temperature level at the 0 degree, that is the water existed as a ice. Then at 100 degrees Celsius, water is boiling and it converts a liquid into the vapor state. Lowers the temperature, vapor, it gets converted into the liquid. That science is divided into three parts. First of all, we are going to see the chemistry. Chemistry is the study of substance and the reactions. And you know that substance means what? Each and everything that we are unable to see in our everyday life in the form of matter or substance, that is, and its reactions. For example, have you ever seen the change in color of mango? Have you ever seen the change in color of apple? It is the chemical reactions that takes. Next part is physics. Physics is the study of matter and energy. Consider it as a pen. So it is made up of the particles, and each and every particles, they are arranged. The arrangement of particles is different. In the solid, it is very compactly arranged, and so that the particles are vibrating. Next branch of science is biology, where we study living organisms, including plants and animals. Four main states we are expressing. First of all is solid. The particles are very compactly arranged, and their position are fixed. But still, some particles are in vibrations, not moving. They are vibrated, and due to that, fixed structures are the very compactly arranged. Due to that, it having a definite shape and having the uh, volume. Volume means what? The amount of substance that required the three-dimensional space to keep it. It is called as the volume. And the volume is depends on the structure of the substance. Okay, now so the solid has fixed shape, or you can say definite shape, and volume. Its structure is like this. These are the particles which are very compactly arranged, and you can take an example as ice or the frozen water. Uh, Also, you can say, take the example of gold, where the particles are very compactly arranged. And one more thing, taken state of matter is liquid. In liquid, as compared to the solid, the particles are so arranged so that their distance between particle is more as compared to the solid. And that's why the liquids can flow. Due to this type of structure of this liquid, see that the particles are arranged, so, as compared to solid, the interparticular distance, particle distance is very very large, and due to that, it having the definite volume, but it takes the shape of container. It takes the shape of container. For it has a fixed volume as the capacity of the container, or you can say the glass. What is the capacity of the glass? That is the volume, and the shape of the glass, it actually acquires by the water. So that water is having definite volume but not having the definite shape. It takes the shape of the container. Okay, next, that examples, water in glass. Depend upon the shape of the liquid, it acquires the shape of the container, and accordingly it has fixed volume but not having the fixed shape. But main point is that the in case of solid, they are having the definite shape and definite volume. Here having definite volume but not definite shape. Now gas. In case of the gases, the particles are very very far from each other as compared to the solid and liquid, so that gas can flow from one place to another place. One more state is there, that is the pla plasma state. Plasma states, it occurs very rare in on the earth surface. The examples of this plasma state is the lightning. Then next, there is a Bose-Einstein state. Okay, now we have seen that what is the science, that is the systematic study of any subject which is based on the observations, experimentations, and conclusions. You can simply say that science is observation plus experiment plus conclusions. These are the life examples, and this science is divided into three parts: physics, maths, and chemistry, biology. Okay, then what is chemistry? It is about the study of matter and reaction. What is physics? Study of matter and energy. What is biology? Study of living organisms. Now we have seen that the four main states of the substance are the matters which are depends on the temperature and pressure and volume. And we have seen that solid, liquid, gas, plasma, and both Einstein states. Now we are going to study the matters. That matter is nothing but whatever you are observing or whatever you have seen in this room, whatever it may be. It may be door, fan, chairs, whatever it, that is called as matter or substance. This substance is made up of very tiny particles. As I given examples of the chalk, when I crush it, it will be broke down into the very smallest particles, and that is nothing but the atoms. We are going to see what is mean by atoms. Atoms, molecules, and elements, compound, and mixture. Mixture that we are going to see. Now, first of all, this is very clear to all that atom is the very smallest particle of the matter. Matter, atom is a very smallest particle, very smallest particle of the matter is called as atom. Okay, now we can say that when the substance is made up of, or we can say that when pure substance is made up of only single atom, then it is called as element. A pure matter, element. Element is what? A pure water, sorry, a pure substance, or any substance you can say, pure substance. A pure substance is made up of a single atom, made up of a single atom is called element, is called element, is called element. For example, gold. Gold is used in a jewelry that is made up of the only one particle, or you can say the one atom, that is called as the element. So gold is a element. So uh, as of now there are 118 elements are present in the universe. Okay, for examples, the carbon, hydrogen, oxygen, neon, sodium, magnesium, aluminum, silicon, sulfur, chlorine, argon, potassium, calcium. These are the elements. These are the elements. So pure substance made up of single atom is called as element. Then example, example, examples are hydrogen. It is represented by the letter Z. It is the symbolic represent of the element hydrogen. Helium, it is represented by He, etc. Then let us see about compounds. Compounds. Compound is formed when two or more elements, when two or more elements chemically combine with each other, and the product which is in the reactions which will get, which has the characteristics different than the constituents elements or atoms. Compounds are formed when the two or more elements chemically combine each other. Compounds are formed by two or two or more elements chemically combined chemically combine each other. Chemically combine each other. That means the compound is formed by the bonds between the atoms. For example, hydrogen gas. Example, hydrogen gas. Hydrogen gas. Its formula is HH. So it is formed by the two elements hydrogen H2. You can say that it is H2. H2. Another one more example you can take that CO2, that is carbon dioxide gas, CO2, and it is formed like this. So this is the bond between the oxygen and carbon. See, this is a carbon, this is oxygen. There is a covalent or whatever bond is formed between the elements or atoms. So here are two elements are participating, oxygen and carbon, and we are getting CO2. So this is the compound. This is the compound. We will get the compound CO2 by when two elements carbon and oxygen mixed together or chemically combined with each other. That is hydrogen gas. When the two hydrogen elements combine and form hydrogen gas. Then mixture. Then mixture. What is mixture? When the two or more compounds together form the mixture. Two or more substance. Two or more compounds. Two or more compounds chemically combine to form mixture. To form mixture. For example, what are the examples of the mixture in our everyday life? Yes, tea. Tea is a very good example of the mixture because tea is made up of sugar, then water, uh, uh, green leaves. Uh, these are the ingredients which we required for making the tea. So it is a mixture of many compounds. Mixture of many compounds. So compounds, when two or more compounds chemically combine with each other and form mixture. For example, the salad that we uh, add, you can add in your everyday life in a diet. So that is the mixture of vegetables, and that vegetables are made up of the compounds. When compounds together form mixture. So this is the salad. You can say the vegetable salad. vegetable salad. It is a very good examples in our everyday life. That is the example of mixture. So we have seen that the matter is exist in three forms, depends on the temperature level and pressure and volumes and the arrangement of particles. And then we have seen that atom, that is a very tiny particles of the matter. Again we have seen element, that is a pure substance, is made up of single atom, then we can say that that atom as a element. So today, as of now, we have 118 elements present in the universe. And for example, we can take as a hydrogen, helium, etc. Okay. uh, Now in afterwards we are going to see that the first 20 elements, we are going to see now what is the atomic structure, how it looks, and what exactly inside the atom, what can you found, and how can you describe the structure of atoms. That is very interesting to know, because this is very important as you are going to study the first chapter of the class 10 CBSE, where it is very useful. So first of all, structure of atom. Structure of atom. Structure of atom. So it has a two parts. One is one is this is the outer part. You can say that outer part. Then in there is a inner part also. Inner part. In the inner part there are the particles, positive P and N. P plus N. P means proton, N means neutron. So inside the center, or you can say the inner part of the atom, we are having two charged particles, proton and neutrons. So here proton, P for proton, P for proton, which having the positive charge, positive charge, positive charge. Then neutron, no charge, no charge. That means neutral. Then we are having the extranuclear part, or you can say the outer part, and this outer part is occupied by the electrons. 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 These are the electrons which are occupied in the outermost part, and this outermost part is called as the shells. That means electrons are occupied in the shells. So electrons is another charged particle having the negative charge. Neutron, see neutron, no charge, or neutral. Neutral. Then electron having charge negative, negative charge, occupies in outermost part, occupies in outermost part in shells. You can say outermost part is nothing but the shells. So it is always occupied in the shells. So number of electrons which can be accommodated by the particular shell, which having the formula, that formula is 2n square. See here, the number of electrons occupied in each and every shell is given by the formula. That is very important formula, that is called as the 2n square. 2n square is the formula for calculating the number of electrons carried by the particular shells, or you can say the outermost orbit. So first of all, electrons, number of electrons occupied by the particular shell is given by the formula 2n square, 2m square, where n is equals to number shell, or you can say the shell number, shell number, shell number. So here n equals to 1, 2, 3, 4, etc. Okay, so this is the nucleus. This is the nucleus. Inside the nucleus, proton plus neutron charge is there. Proton having positive charge, neutron having no charge. So due to the proton, this nucleus has positive charge, and in outermost orbit, or you can say the outermost part of the atom, that is called as the shell, and that shell is occupied by the electrons. So this is the first shell. You can draw the one more shell. You can draw one more shell. Okay, you can draw the one more shell. Likewise, you can draw the number of shells. So first shell is always a K shell. First shell is a K shell. Second shell is L, alphabetical L. Third shell will be M, and so on. That means according to the alphabetical order, K, L, M, N, O, P, Q, R, like this. So first shell will be start from K alphabetical. Next shell will be start by L. So in K shell, K is the first shell, that means N is equals to 1, and L is the second shell, then N is equals to 2. For the first shell, for the first shell, that is K shell, the number of maximum electrons that shell can occupy is given by the formula. This formula is common for every shell. For first shell, the K is, that is K shell, and number of electrons for K shell will be, number of electrons for K shell is equal to 2n square, as the K shell is the first shell from the nucleus or the center. So it's n equals to here 1. So it is 2 into 1 square, it is equals to 2. So in K shell, 2 electrons, maximum 2 electrons can occupy, means it is the capacity of that shell. It is the capacity of that shell, K shell. Capacity of K shell is 2 electrons. So capacity of electrons, or you can say the number of electrons for K shells, or you can say the capacity of K shells, that is 2 electrons. 2 electrons. 2 electrons. So similarly, you can find out the capacity for of L shell. capacity of L shell. You can find capacity of L shell. How it can be find out? Yes, very simple, because I already discussed that it is the same formula for each and every cells to find out the capacity for each cell. So capacity of L shell, you can find that formula is the same. So only you have to put the values here. 2 n is equals to 2 and its square. Here n is equals to 2 for K shell. Sorry, L shell. That is, as it is the second shell from the center or the nucleus. That's why it is. So 2 into 2 square means 4. So it is 8. 8 electrons. So second shell's capacity is 8 electrons. So likewise you can find out the capacities for the next shells. So that you can easily find out the capacity of each shells. So it is the homework for you that you have to find out the capacity for the shells up to n shell. Okay, one more 2 shells you have to. Already I have given 2 shells, 2 more shells you have to calculate the capacity for that. So we have seen that this is the structure of atom. At the center there is proton plus neutron, and proton has positive charge, neutron is no charge, electrons having negative charge. Inside the nucleus, these are the inside the nucleus. Inside nucleus or center or center, and electrons is in outer part, that is called shells. That is called shell. So accordingly you can, so as you know that the second shell's capacity is 8. So there are 8 electrons will be there. 8 electrons will be there. 8 electrons will be there. Okay, likewise this bar is considered as a negative sign. Okay, so there are 8 electrons in the second shell. So as you know that inside the nucleus there are proton and neutrons, and due to this charge particle in the nucleus has positive charge. It is because of the presence of proton, and in the outermost part electrons are moving or revolving in the orbits, in circular orbits, and the capacity of each orbit is fixed. It is given by the formula 2n square, where n is shell number, that is the, you can say, the orbit number. It is the first orbit from the nucleus, so it is denoted by k orbit or k shell. Then second shell will be L shell, which is the second shell from the nucleus. So it's for that n is equals to 2. So accordingly we have find out the capacity for K shell and L shell. Okay, now we will see that the first 20 elements, name of the first 20 elements with their atomic number. Now we will see that what is mean by the atomic number and what is mean by the atomic mass number. We will see that atomic number and atomic mass number. Atomic number means what? The number of electrons. Atomic number, it is always denoted by capital letter Z. So it is the number of electrons. Number of electrons present in the atom. Present in the atom. It is called as atomic number. So atomic mass number is called as atomic mass number. Atomic mass number. It is always denoted by alphabetical letter A, and it is the number of protons plus number of neutrons plus number of neutrons, that is P plus N, that is equals to A, and that is Z is equals to number of electrons, number of electrons. One thing you have to remember, that number of protons and number of electrons always equal, so that the atom is electrically neutral. Okay, so present that number of protons and number of electrons are always present, so you can say that Z equals to E equals ER P, number of electrons or number of protons. Then atomic mass number, that is the number of protons plus number of neutrons, is called as atomic mass number. It is represented by the capital letter A as equal to P plus N, and this atomic mass number is nothing but the mass of atom. It is represented by atomic mass unit U. Its unit is U, atomic mass unit. Atomic mass unit. It is represented by U. Okay, so according to the atomic mass numbers, we are having some elements. First 20 elements according to their atomic mass number with their symbols, we are going to see now. Okay, so first of all, very important topic as an exam point of view, as it is many times asked in the examinations also. First 20 elements. First 20 elements. First one is element is hydrogen, symbol, and atomic number. Atomic number, that is represented by Z. Okay, first one is hydrogen. Atomic symbol is H. Atomic mass number is 1. Sorry, atomic number is 1. Next one is helium. It is represented by He. Atomic number is 2. Lithium, it is Li. 3. Beryllium, Be. 4. Boron, B. 5. First of all, I will write the first 20 elements, then we will write their symbols and atomic numbers. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, chlorine, argon, potassium, and calcium. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, phosphorus, sulfur, chlorine, argon, potassium, calcium. So this is the boron, which is represented by the capital letter B. Its atomic number is 5. Then carbon, it is represented by the letter C. Atomic number C. Nitrogen N, atomic number 7. Oxygen O, atomic number 8. Fluorine F, atomic number 9. Neon, Ne, atomic number 10. Sodium Na, atomic number 11. Magnesium Mg, atomic number 12. Aluminium, atomic number 13, represented by Al. Silicon Si, atomic number 14. Phosphorus P, atomic number 15. Sulfur S, atomic number 16. Chlorine 17. Cl 17. Argon Ar, atomic number 19. Potassium K, atomic number 19. Calcium Ca, atomic number 20. We are going to see that the electronic configuration. Electronic configuration is nothing but the arrangement of electrons is called as electronic configuration. Distribution of electrons, or you can say the shell wise distribution of electrons is called as the electronic configuration. Electronic configuration. It is called as the shell wise distribution of electron. Shell wise distribution of electrons. So as the hydrogen having the atomic number 1, so that means it is there is only one orbit, and in one orbit there is only one electron is there, so its electronic configuration is written as 1. Helium is having atomic number 2, so in the outermost orbit or the outermost orbit is the first orbit here. Okay, because its capacity, we know that the first shell capacity is 2, so it is outermost orbit having 2 electrons, so its electronic configuration will be 2. Lithium having atomic number 3, so its electronic configuration will be, it is, see, this is the first shell where you can see that K shell, here also K shell. So here in K shell there are 2 electrons will be there, then one more electrons that will be occupied in the next shell, that is 1. 2, 1 is the electronic configuration for the lithium. Okay, then for beryllium, electronic configuration will be 2, 2. Here two shells, one K shell and L shell. In lithium, in K shell 2 electrons, in L shell 1 electron. In beryllium, in K shell 2 electron, and remaining electron will occupied in next shell, that is L shell. So in boron, 5 electrons are there. So 2 electron in first shell and 3 electrons will be in second shell. For carbon, it is 6 electrons are overall 6 electrons are there. Out of 6 electrons, 2 electrons will be filled in first shell. Remaining electrons goes to the second shells. Again nitrogen, in first shell 2 electrons will be there. Remaining electrons will be in second shell. Because the first shell having capacity 2, its capacity is full. So the remaining electrons will automatically goes to the next shell till the its capacity full. It will then transfer to the next shell. Okay, for oxygen having electrons, 8 electrons in the outermost orbit. So for 2 electrons will be in first shell, 6 electron will be second shell. For fluorine, it is 9 atomic number. So 9 electrons are there. First 2 electrons will be in first shell and 7 electron will be in second shells. So likewise, you can uh, uh, do the electronic configuration. So in the next one, that is a neon having atomic number 10. So in first shell will be 2 electron, second shell will get 8 electron. Now in sodium, so in sodium total number of electrons 11. For first electron will be having 2, second electron will having 2. It is 2 plus 8, 10. 1 remaining, it will goes to the next shell, that is KL M shell. 1 electron will be M shell. 2, 8, 1. Here you have to think one thing you have to remember, that is comma. It is separated by comma. Comma is separated. Shells are separated by comma with their capacities. So in magnesium, atomic number is 12. Total number of electrons 12. First 2 electron will be in first shell. In second electron will be occupied the 8 electrons. 2 plus 8, 2. So remaining 2 electrons will go to the next shell. So likewise, you can calculate the electronic configurations of the elements. In aluminum, 13 electrons are there. So its electronic configuration 2, 8, 3. In next 2, 8, 4. In case of silicon, 14 number of electrons are 14. In phosphorus, 15 electrons are there. So it is 2, 8, 5. In 16, it is 2, 8, 6. 17, 2, 8, 7. 18, 2, 8, 8.